Hi, I'm Alix Paultre with Aspencore, and I'm here with my good friend Steve Oliver from Navitas. They're a wide-bandgap semiconductor manufacturer, relatively new one at that. I'm glad to see you here, Steve. Glad to have you here.
It's good to see you again, Alex. It's been many times we've seen each other.
Yes, it has. Great times. Now, Navitas is a relatively new company. How old is it exactly?
Navitas was formed at the late 2013 into 2014, so we're a young company. But let's just say experienced guys in the company, bringing a lot of experience from the marketing side, the technology side, the business side, the application side. So everything coming from the world of power semiconductors and power supplies now being applied to the GaN power ICs.
Mm-hmm. Well, I've known you for over a decade and a half. So, I mean, as you as an example, you're an industry warhorse. Everybody knows you. And most of them like you.
I hope so.
But seriously, though, the issue with GaN and wide-bandgap semiconductors and silicon carbide is we're really in the phase where can we stop worrying about the educational aspect? Can we move on to commercialization and sales? Or is it still a bit to go?
That's a very good question. I think GaN suffered the hype cycle probably 10 years ago, where really it was still an academic tool. And over the last 10 years, the technology has vastly improved. We've gone from depletion mode, normally on devices, to enhancement mode. And now we've got to the stage where we can reliably produce 6-inch wafers, we can package them successfully, and also now we have the lateral integration now, the driver and the FET on the same die. That really opens the door for industry adoption. And it's not just the GaN technology that is enabling that. If we look back to 40 years ago, 1977, we had the culmination of the hex FET, the MOSFET came out, the first Silicon General PWM IC, we had new magnetic technology, and that allowed previously academic topologies to become industry mainstream. And in the next 5 to 10 years, an amazing shift in efficiency, size, and cost in power supplies. We come to today, we've got GaN technology with integration. We've got some new control ICs. We've got some great new magnetics from guys like Hitachi, TDK, Ferox Cube, and again, previously academic topologies like the active clamp flyback converter, which was introduced in 1996, but only this year we've seen commercial ICs available, which really opens the floodgates. Now is the time for adoption.
And that's it. So it is. Now is the time for adoption. But then again, I think also market pressures are going to come to bear because as competitors start incorporating the technology, you're going to have to keep up or get out.
Yes, that's correct. We're working with customers. First of all, the power supply customer in the consumer, the mobile space, but also the end customer. And so working with the power supply company, we say, we've got a great new technology. They say, not sure if our end customer is interested yet. We talk to the end customer, they say, wow, where can I get this? And we close the loop. So for me, it's a push into the power supply companies, and it's a pull through the end brand.
And that makes a lot of sense because, well, when it comes to customer wants, you try to create a want, right? But you can only service a business's needs. A business isn't going to magically develop a want because you tell them they need their diodes in blue, you know?
That's correct. You have to go through the proof points. It's not good enough to say this material is better than that material. You have to say this material with the integration and a new magnetic and a new topology makes this half the size of what you had before at the same cost. That's a gimme.
Right. Well, and I think it's very important to point out that in the case of electric vehicles or in the case of Internet of Things, portable small devices, everyone's focusing on the battery. When in reality, if you can shrink your power supply and increase your efficiency and eliminate a lot of your passives and change your form factor, you can go a long way to addressing energy storage issues.
That's correct, and you mentioned going a long way. Obviously with a car you've got energy in the battery, but if the change from battery energy to motion can be made more efficient, that car will go further. That cell phone will last longer. So it's all about using that power conversion in an efficient and also small and light way. I don't want to carry a sleek, sexy cell phone and be carrying a brick around with me to charge it. So the two have to go hand in hand.
Exactly. Now, and speaking of hand in hand, how much support do you give your customers once the product's out the door? Do you help them dial it into their development? Do you give them a development board? Do you help them dial it in for their application reference designs?
Yes, obviously it's a new technology. So GaN itself has had time over the last 10 years to be understood by engineers. So they know going from silicon to GaN will give them a benefit. But like anyone, like myself, I still need to learn. I need to hear about new ideas, try new techniques. So going from slow silicon to fast GaN, then you need to think a little bit more about which ferrite to use, how to lay out the board. So we help customers with reference designs, obviously with data sheets, application notes, design tools, so they can get it first time right. That's
Excellent.
very important. The material itself is very fast, high switching frequency, high slew rates. We want the design to be fast as well, a fast time to market for the customer.
Well, I was mentioning to someone earlier, it's almost today as if instead of just-in-time manufacturing, you have to do just-in-time design.
That's correct.
You know?
That is correct.
Now, before I let you go though, Steve, do you have a final word for our audience?
I think this has been a very good conference. It's the first one for the Power Conference, and obviously Aspen Core, you're representing here today, and Bodo have done a very good job arranging it. The rooms have been full. It's been a very tight session. Some very good people, good conversations, and an industry that's really working together. It's not a set of rivals. It actually feels like more of a team.
A fraternity.
A fraternity, yes. I like that.
Well, I'm glad to be part of it. Thank you, Steve.
Good to see you again, Alex.